nampak tanda record dekat your name? Okay, dah ada. Right, so yeah, welcome back everyone. So kita mula, wait ya. Okay, this one. So we continue with example 1.6. So evaluate limit x equals to 0 for sine x squared over 5x squared. Okay, so this one, if you already got some basic understanding, by looking at it, you know that you can apply squeeze theorem. Okay, in this solution, it shows use substitution technique. Okay, but before I discuss about this, maybe I can also show you if you can solve this by using directly without using use substitution. Okay, because this is just a simple question. So we've got here limit x approach to 0. Okay, sine x squared over 5x squared. Okay, we have 5 here, so 5 is a constant. So according to the property limit, you can take it out from the limit. Okay, so you can write it down like this: 1 over 5 limit x approach to 0 for sine x squared over x squared. So previously we have learned about squeeze theorem. It says limit x approach to 0 for sine x over x. So this is actually, even though in this question we have x squared, this one over x squared, okay, it is actually the same thing. We can still assume it equals to 1. So basically this is equals to 1. So your final answer will be 1 over 5. Now, as for using the use substitution technique, okay, here you need to define, okay, u is equals to what? So here we define u equals to x squared. Okay, our variable that we want to substitute it is x squared. So when you change this, okay, this is the real question, the original one. Limit x approach to 0, sine u over u. Okay, you think you can solve this one? Is there any mistake in this, the way I wrote this down? Anyone can point it out?
Constant.
Come again?
U to 0.
Okay, betul. Correct. Okay, we still got this x equals to 0, but our variable here is no longer x. We already convert it into u. So it means that you need to change it. Change the x equals to 0 to become u as well. So you need to make an assumption. Okay, so you write it down like this: as x approach to 0, so we assume x squared is approaching 0 too. Therefore, u approaching 0. So the correct one, okay, is limit, okay, u approach to 0 for sine u over u. So you need to do this assumption. Once you choose u equals to 1, you need to do the following step is you need to make an assumption to change the x approaching to 0 to substitute with u. Okay, then only then you can apply, okay, you can apply, we have 5 here, yeah, so you can apply the property limit by taking out the constant. Okay, so this will become not x, it's u approach to 0 sine u over u. So here if you look at this, this is also a squeeze theorem. So you know by default it will become 1 and your final answer is 1 over 5. Is that clear? So basically when it involves trigonometry function, limit involving trigonometry, actually we already covered this in example 1.6, you're going to use a lot the squeeze theorem, the two squeeze theorem that we've learned, sin u over u and the 1 minus cos x over x. So you need to remember that. Okay, this just direct plug in. Okay, try to solve this one, just a quick one. So what will be your answer for this? Just use a direct substitution.
11/2.
Yep, correct. I hope everyone is doing as well, not only Leah. Try to solve it. So it is 11/2, yeah? Now we move to solving limits using algebra techniques. Okay, this is the fun one because lots of algebra techniques we covered here. Just now, it's very simple. Even though you find rational functions, but we still can solve it because the denominator, kalau dalam bahasa Melayu kita sebut penyebut. Okay, penyebut tu masih ada value. It's not zero. Now, in this example, we're going to see what happens if the denominator is zero when you direct plug in. Okay, penyebut dia jadi kosong. So for example, if you look at this, okay, if you try to direct plug in, what will be your answer for this? This one, if direct plug in, it will be
0/0.
0.
okay, 0/0. So you think, okay, yay, finish, very easy. And then you move to the next one. Okay, if you direct plug in, what will be the answer for this?
Okay. 0, 0.
Okay. You'll get 0/0 to
Yes, may error.
Medera terus. Lepas tu ingat, okay, dah siap. Okay. Tak siap it's not complete and it is actually wrong. Okay. So in this type of question, it means that you need to apply factor and cancel method. So basically macam you need to do lots of exercise just to know whether these questions need a direct plug-in or other suitable methods. So in this case, you need to apply factor and cancel method. So about this one, okay, this is x cubed minus 1. So x cubed minus 1 is actually, if you can expand it, you will get x minus 1 times x squared plus x plus 1 over x minus 1. Okay, so you need to solve this one first. Okay, so here you know that once you factorize this, you factorize the numerator, only then you can cancel it out, the term. Okay, for example, you can cancel out here x minus 1 over x minus 1, and what's left is that you'll get limit x approach to 1, x squared plus x plus 1. So the answer will be
3.
yep, 3. Okay, faham Now, we move to the second question, this one. Anything, which one you need to factorize?
Atas
Numerator
bawah.
alone?
Semua
Come again?
dua.
Yes, true, semua. Cuba selesaikan dulu. Try to solve this. You need to factorize both the numerator and denominator. So the numerator, if you factorize, it will become what?
Numerator. Sekejap teacher.
Lia je yang buat, yang lain buat tak? Ke yang lain tunggu standby je jawapan. So cuba you need to try by yourself Okay, good. numerator dulu. Numerator is very simple one. So we
2
factorize 2
2
good.
minus x.
4 minus
4
x.
minus x. Okay. Now we go to the denominator. The
X minus 4,
denominator
x plus
is
x minus 4, x
so
plus 3.
x minus 4, x plus 3. Betul?
Yes.
True.
Yes.
Okay. Now, if you look closely, tengok betul, closely you look, this one and this one can cancel out, supposedly, but you cannot straight away cancel it out until you do something. Am I right? What the things that you need to do?
Remove negative.
Negative.
Exactly. So, yeah, put
Okay,
negative here so that it will become x
x minus x plus
minus 4. Okay, because we want to cancel out with the denominator,
x minus 4.
the same term. Okay,
Yeah.
ini kan, I don't want to teach you how to do this. I expect that you already know about this, yeah, because this you have learned several years before you coming into university. So I expect that you already have the strong knowledge on algebra. Okay, don't ask me why I need to do that. Nanti nak kena dengan saya. It means that you need to go back and do some revisions on this. Boleh ya? Otherwise, I don't have enough time to finish up my lecture plan. Clear ya? So once you obtain this, you can cancel this out. Okay, and then what's left is that you've got this minus
2 over 7.
2 over, terus sabar. Step by step. Okay. Okay. Once you obtain the correct one, okay, then only then you can write this. Hence, limit x approach to 4 for this function, okay, is equal to, only then you substitute the x value here. Then you will get minus 2 over 7. Is that clear?
Doktor, yang limit tu memang kena tulis
Kena. Ini I'm waiting for you to ask me this. You have to write down the limit.
Oh my
It's
God.
a proper way to do limits. Okay, limit solution. Okay, you can ignore the limit when you solving this part. You can ignore it. You want to solve the algebra part, kan? So once you get the final solution for that algebra part, only then you write down the limit for it. Okay, many students, previous students, they just ignore it till the end. Tak tahu lah, rasa macam if you in my shoes, you geram juga because you don't know whether that student understand or not. Okay, so the proper way, the correct way, okay, you can ignore the limit function. Okay, you don't want to put limit over here, it's okay. Okay, some people they tend to write it down lah. Actually, I prefer this way too. Okay, but I don't want to burden you. So you can ignore to write limits starting from this line. Just concentrate, finish up the algebra. Once you get the correct term here, only then you write down the limit function. Okay, is that clear?
Maksudnya kalau tak
Jelas,
letak limit tu salah.
Bukan
Dia
salah. I'm afraid that you
Oh.
you may you faham tak? Macam mana nak cakap
Maksudnya tak boleh terus answer lah.
Saya nak bagi
Tak boleh letak
analogi.
jawapan terus lah. Maksudnya kena tulis limit tu dulu untuk proof. Gitu ke?
I prefer you to do it the correct techniques lah. Faham tak? Because you are dealing with limits. Okay. So I prefer if you can write it down until the end lah sebenarnya. Sebenarnya ikutkan the correct way. Okay, kalau you look at other solutions, dia akan, the limit parts will be write down line by line. So I don't want to burden you that way. That's why that is the reason why kan I put this kind of, you solve this one, okay? this part you solve, you can ignore it, and then for the final solution you can put the limit. Okay? Boleh? Dia macam you
Boleh,
solat lah. You solat kan, cakap bahasa Melayu lah. Sorry Fatullah, just an analogy. If you pray, bila you solat, you duduk antara dua sujud tu, kalau you tak baca, sah tak solat you? Ya, sah tak solat you? Sah. Tapi kalau you baca, you dapat pahala. You faham tak? Sama konsep lah bila you buat limit ni. You boleh abaikan, tak nak, you nak buat terus lompat pun boleh. Boleh, terima. Tapi saya sakit mata dan there is a high chance that you will make a mistake. Susah saya nak cakap, I cannot explain it because through my experience, memang I minta you tulis, memang you kena tulis. So analogi dia macam di solat lah. You can skip that bacaan Rabbi fili warhamni wajbuni. You can skip that part. If you don't want to recite it, that's okay. Allah still accept your pray. But then you will miss the doa, the benefits of that doa, you know? Okay? Cukup saya faham. Macam tu boleh faham Saya tak perlu lupa lagi.
Faham.
Dia sebenarnya tak perlu tanya, tak perlu jadi isu besar pun. If I ask you to write down, you write down. Itu je. Okay, exercise 1.6.
Okay, thank you.
Okay. Dia macam kecil hati saja. Tazkirah pagi. Okay, try to do exercise 1.6, number 2 Roman. Ni very simple ni, tengok pun tahu ni. I think there's a mistake with this question.
Jawapannya
Let me check.
satu tu.
Let me check. Sekejap. Okay, rasa betul. So apa jawapan dia? What is your answer?
1.
1. Is
Bukan,
everyone getting 1?
6.
Bukan salah.
Apa jawapan dia?
6.
6 kot.
6 kan? Should get
Yeah.
6, right? Wait. Okay,
Yes.
should get 6 kan? Betul Okay, you should get 6. Okay. Now we move to expand involving binomials. Okay. Okay, this one, binomials. We did that in our first example tadi sebenarnya. But anyway, you can look at the solution for the first Roman here. So this is, if you straight away substitute, direct substitution, you'll get 1 minus 1, 0. This is also 0, betul? How about this one? This one pun also. Ni berapa dapat if you direct plug in?
0/0.
Negatif 8/0.
This also 0/0 kan? Okay. Now, this involving binomial, so it means that you need to expand it. Okay. So for the first Roman question here, x squared minus 1. Okay. It is actually x minus 1, x plus 1. Okay. So you need to expand this. This is similar to our first example tadi yang x cube minus 1 tadi tu kan. So this one only x squared minus 1. So you can cancel out this. So it becomes 1 over x plus 1. So you can put your limit 1 over x plus 1. It will become 1 over 1 plus 1. So 1 over 2. Okay. So that is the answer. And as for question number 2, okay, this is quite a tricky one because it involves binomials but with the cubes. Okay, 2 plus x in the bracket power of 3. Okay, so you need to use this. Okay, this is the shortest way. Okay, there's a rules. Okay, that you can memorize it. Okay, so in short, if you plug in, you will get the solution. Okay, you'll get the first one here, you'll get this as a solution, and then just plug in. Sorry, not plug in, you expand it. Once you expand it, only then you can cancel out. So we have x term here, so you need to cancel out this one, and what's left is this, only the numerator alone. So only then you can substitute the correct answer, substitute the x to get the correct answer, which is 12. Okay, maybe we can do some exercise, the simple one, just to, okay, try to answer the first Roman here. So you need to expand the binomial terms here. So it will become
minus 2.
come again. What is your answer?
Minus 2 plus 2.
Minus 2 plus 2. So we can cancel this out. Betul? So what's left is that we have hence limit x approach to 1 for x plus 2. So your final answer will be 3. Okay, boleh? So this question you can do at home. Actually, it's very easy juga. So you should get the final answer 6. Okay, can try to do it at home. Now, if I may proceed with the third method, getting a common denominator method. Okay, dah salah soalan? Already copied this question. Let me check how long we... Okay, still got time. Okay. Now, getting a common denominator method. You need to find the least common denominator. Ni istilah je ni. It's just okay, what does it mean? If I can put some example, just
Doctor, could you repeat the
Yes.
question for homework?
Oh, for the homework. Okay, sorry.
Yeah.
This one. Limit x approach to 3, x squared minus 9 over x minus 3. I already shared with you guys the tutorial questions. I did that, right? Yesterday or on Sunday?
Yes.
Yes. Can someone share it again? I'm not sure whether Dika. Is Dika here in our class? I don't know. Let me check. Okay, Dika, are you here?
Yes.
So
yes,
if
there.
you okay, so can you follow?
Yeah.
Okay, good, great.
Yeah.
So about the tutorial question, I think you can contact Azri or other friends as well to get the questions so that you can prepare for your tutorial tomorrow morning. Okay.
Okay.
Unfortunately, I am not the lecturer for that tutorial session. So you may need to introduce yourself to that lecturer, Dr. Nazib. Okay.
Okay.
Alright, so you've done this. So may I proceed with getting a common denominator? Yeah. So if I can give one short example, okay, just to get the brief idea. So last time, if you want to solve this type of question, so how can you do this? Okay, I don't want free. Let me change it. Okay, come again. Sorry, I changed the question. So how can you solve this?
Samakan pembawah.
Yeah, you need to get a common denominator. Common denominator is samakan penyebut. Okay, so to get the common denominator, since 1/4, okay, in 2 we have 4, so you just time up with this one, 2/2, am I right? So that you will get, okay, apa yang you dapat is 2/4 minus 1/4. Am I right? So your final answer is 1/4. Betul? So this is the same concept that you want to apply when you want to solve the limit question. Okay, you need to apply this concept. Okay, this is what we call getting a common denominator method. Senang je, you have done this before. Okay, shouldn't be a problem. So let's say example 1.9. Okay, it's just that this time it plays around with more variable x. Okay, macam ni lah. Now, if you look example 1.9, 1 Roman, okay, you need to find limit x approach to 0, 1/x minus 5/x squared plus 5x. So the solution is that, okay, I know that you already, if you think quick, fast, you know that you need to do something with this term, betul tak? You need to get the denominator for this term following this, am I right? So to do that, however, you need to solve this one first. This one, you need to factorize it. Okay, you need to factorize it. So it will become 5/x times x plus 5. Okay, once you have factorized it, it means that the first term here, you only to times up with x plus 5/x plus 5. Okay, do you understand? Is that clear?
Could you
Okay,
repeat?
I hope that one is clear, yeah? It's very simple sebenarnya. So you just adjust the fractions, okay, based on the LCD. So this is the one that you already factorize it. So this second term is actually 1/x, but we already times up with x plus 5/x plus 5, so that we will get the denominator. Okay, the denominator will be the same. So once the denominator is the same, so you can combine the numerator, you can combine. So x plus 5 minus 5/x plus 5. Okay, it's just similar like the one example that we did here. Okay, so here, once you already combine it, so you can also write it down as 2 minus 1/4. Betul tak? It's the same condition or equal condition. Okay, so similar to that. So that is why we can combine it. So you can solve it. So plus 5 minus 5, you'll get x over x times x plus 5. And you can further cancel out the x term. Okay, so your final one function is 1 over x plus 5. Only then you can plug in your limit. So limit x approach to 0 for 1 over x plus 5. So your final answer will be 1 over 5. Is that clear? Yeah. It should be easy. Okay. Now we go to the second question. Okay. So if I can delete this one. You already clear about it. Before that, let me check how many times left. Okay, we're going to end the session soon. So maybe you can write it down this one first. This example. So in this example, you need to factorize the denominator at the first term, and you need also to factorize the second denominator here. Okay, so try to do it. Try to solve it. So if you already get the idea, so the first term here, you need to times out with what?
X plus 2.
X plus 2.
Over x plus 2, okay? So you end up with this one, x plus 2 over 4x minus 2, x plus 2. So that it will be, so that the denominator here, okay, will be the same as the second term here, x minus 2, x plus 2. So once denominator, okay, I forgot about this one. We also have 4 here. So what we need to do with 4? It means that the second term here needs to times out with 4 times 4 as well. Okay, so this one needs to times out with 4 times 4 over 4. Okay, 4 over 4. Only then you can have the same denominator or common denominator. So we can combine this since it is already the same. X plus 2 minus 4 over 4, x minus 2, x plus 2. Okay. So next solution, you solve the first at the numerator. Okay, you solve the equations there. So it will become x minus 2, okay, over 4, x minus 2, x plus 2. So you notice that there is a term that you can cancel out, which is x minus 2. So we cancel out this one. So what's left is that 1 over 4 x plus 2. Hence, plug in the limit value x approach to 2. For this function, you will get, what is the final answer? 1 over 16. Yes. Baru betul. Okay. So again, you need to evaluate both sides. Okay. In this question, we have two terms. The first one here and the second one here. And then you need to make sure that the denominator must be the same. Only then you can combine it and solve the any expression from at the numerator and denominator. Cancel it out and only then you can plug in the x value. So is that clear? If yes, then we can move to, okay, maybe exercise 1.8. You can copy this one, both of it. I'm afraid that we're running out of time now. Maybe someone can screenshot this, exercise 1.8. Okay. Let me check. Yeah, it's about time. So please join if it's unexpectedly quit. We need to have another session. I need to finish up until absolute function. So this one, try to do at home. And the final answer for this one is minus 1 over 4. This one is 3. So try to do it at home. I hope you can get the answer for this. Okay. This one is easy. This one is tricky. Try to do the tricky one. Okay. The second Roman is quite easy because this is just like our previous example. But this one is quite tricky. Okay. Need to do it very properly lah. Okay.